All right, so section 5 is our last section for chapter 1. 1.5 day 1, we introduce standard deviation and variance. These are two pretty key words we cover in stats. Today we're going to find out what is a standard deviation and variance and how do you calculate them. So the standard deviation, which we're going to call S, is a measurement that identifies how far away from the mean the observation is. You can think of it as the average distance the observations are from the mean. This is the most common method of determining the variability of a distribution. So it kind of tells you how spread out the data is. Deviation is the difference between, the difference between an observation and the mean of a distribution. And the variance, which is S squared, is the average of the squares of the deviations. Okay, and I know all those words don't mean much, but as we get going, hopefully we at least understand how we find them, and the more we go on this year, we kind of figure out what they really mean and how we use them. So the formulas we have is the variance, which we said is S squared. So it's S squared equals so that top symbol up here means the sum of, and then we have xi minus x bar squared. That means each observation minus the mean squared. And then the standard deviation, which we call S, is equal to the square root of S squared. Okay. So steps for calculating the standard deviation. First, we have to find the mean. Then we create a table to calculate the deviations. Then we find the squares of the deviations and make them positive. The squares will make them all positive. Step 4 is find the sum of the squares. And step 5 is find the average of the squared deviations. So we divide the sum by 1 less than the number of the observations in the distribution. This number is called the variance, which we said is S squared. And then step 6 is to take the square root, and that will give you the standard deviation. Okay, and we can reference these steps. We just have one example, I believe. Actually, 2 examples to do, and then that's it for the day. So in example 1, find the variation and the standard deviation of the following. And they give us that list of 6 numbers. So let's see. Step 1 says to calculate the mean. So to find the mean is x bar. We add them all up. So 10 plus 4 plus 3 plus 6. So add up all the numbers. 10 plus 4 plus 3 plus 6 plus 5 plus 8. And then divide by how many numbers there are. So there are 6 numbers, so we divide by 6. And we end up with 36 divided by 6. So the mean is 6. Okay, so you calculate the mean. That was step 1, find the mean. Step 2 is calculate or create a table to calculate the deviations. So in the table, the observations, that first column on the left, is the numbers. So like 10, 4, 3, 6, 5, and 8. Those are the observations that we had. And the deviations are how far from the mean are these. So this xi minus x bar. So xi is the observation, x bar is the mean. So the first one will be 10 minus 6 is 4. And the second will be the observation minus the mean. So 4 minus 6 is -2. The next one is 3 minus 6 is negative 3. 6 minus 6 is 0. 5 minus 6, we get negative 1. And then 8 minus 6 is 2. So you find the difference from the mean for all these. And then if you actually add these all up, 4 plus negative 2 plus negative 3 plus 0 plus negative 1 plus 2, you'll get the sum is going to be 0. Okay, and that's always true. Because 4 plus negative 2 is 2. 2 plus negative 3 is negative 1. Negative 1 plus negative 1 is negative 2. And negative 2 plus 2 is 0. This should always happen. You don't have to find this all the time, but just that's how it works out. So the squared deviations is you take that number and you square it. So this would be 16. Okay, this is that xi minus x bar squared part. Okay, the second one, negative 2 squared is positive 4. The third one, negative 3 squared is positive 9. Negative 3 times negative 3 is 9. 0 squared is 0. Negative 1 squared is 1. And 2 squared is 4. So the sum of all these, when you add them up, is 34. So you add them all up, you get 34. The sum of the squares of the deviations. So now to find the variance, you would say s squared, which is variance, is equal to 34 divided by n minus 1. So n is how many numbers there are. So in this case, n equals 6 because there are 1, 2, 3, 4, 5, 6 numbers. So it's 34 divided by 6 minus 1. So 34 divided by 5 is equal to 6.8. That's the variance. And then the standard deviation is the square root of 6.8, which is 2.61. Okay, so the yellow boxes, we'll do it in yellow. That's what we were looking for. Okay, so basically you find the mean, then you take all the numbers and you subtract the mean from them. Then you square them, and you add up all the squared numbers, and then you find the standard deviation by dividing by n minus 1. Okay? And we'll do one more example together. Example 2. Over the span of 5 weekdays, the data below represents the number of patients diagnosed with the flu at a local clinic. Find the variance and standard deviation of the data. So they will use this, the data from things like the flu, and the standard deviation and variance tells you how spread out it is. So the first step is to find the average. So that'll be add them all up. 13 plus 23 plus 12 plus 42 plus 55 is 145. And how many numbers are there? 1, 2, 3, 4, 5. So divide that by 5. So 145 divided by 5 is 29. So the average is 29. The second step is going to be to make our table. So right here, second step, create a table and collect the deviations, or calculate deviations. So we have 13, 23, 12, 42, 55. So the deviations would be you take these numbers minus 29. So 13 minus 29 is equal to negative 16. 23 minus 29 is equal to negative 6. 12 minus 29 is negative 17. 42 minus 29 is equal to 13. And 55 minus 29 is equal to 26. And then just so you check if you add them up, they will equal 0. Okay, then we have to do is we have to square them. From here, we square them. So you square the deviation. So negative 16 squared is 256. Negative 6 times negative 6 is 36. Negative 17 times negative 17 is 289. 13 times 13 is 169. And 26 times 26 is 676. So we add them all up. So you square them, then you add up all the squared numbers, and we will get 1,426. So once we find the squared deviations, we can find the variance. The variance is equal to the sum of all the squares, so 1, 4, 2, 6, divided by n minus 1. So in this one, n equals 5, because n is the number of observations. So this would be 5 minus 1. So it's 1426 divided by 4, which is 356.5. That's the variance. So to find the standard deviation, we just take the square root of 356.5. So the standard deviation is 18.88. And that's how you find the standard deviation, the variance, by hand. So some special notes we have at the end. S measures the spread. So it's how far spread from the mean. And it should only be used when the mean is chosen as the measure of center. All right. If S equals 0, that is when there is no spread. So if the numbers are the same, there's no spread at all. This happens when all the observations are the same number. As the data gets more and more spread out, so the farther spread out the numbers get, S should get larger. And as it keeps getting bigger, it's just going to get larger and larger. And the number 4, S, like the mean, is strongly influenced by extreme observations. A few outliers can greatly affect the standard deviation. Number 5, the 5-number summary is usually better than the mean and standard deviation for describing skewed distributions. Use the mean and S, so use the mean and the standard deviation for symmetric distributions. And remember, a graph is the best way to determine if a distribution is symmetric or skewed. So I just want to point out, I'm going to slide up, and if you didn't get all this, you can just pause the video. As I slide up, do you see how in the second, look at the sets of numbers. So here's the second set of numbers, and here's the first set of numbers. The first set of numbers go from 3 to 10, so they're all between 3 and 10, and the standard deviation was 2.61. The second numbers go from 12 to 55, so they're more spread out. The standard deviation was 18.88. So the more spread the numbers get, the bigger the standard deviation is.